to find the domain of all these functions. Okay, just as a convenience for the discussion, I consider same expression under that nth root. Okay, see, the expression is same. The first problem is square root of that particular expression, the second one is cube root, and the third one is fourth root, and the next one is fifth root. Okay, like this you can take any expression, any nth root, right? Not only the square root, cube root and fourth root. You may take any number, right? You may take 100th root, you may take 2020th root of the expression. For all these type of problems, now we are going to find the domain. See, as we know, domain is simply nothing but the possible values of x. Okay, once again I am repeating, we need to identify the possible values of x for which f of x is defined. Okay, there are some values where that f of x is defined, not defined. You need to eliminate those values from the real numbers. Okay, see, we know we already discussed different problems related to this domain. So now when you think about the first problem is what? See, square root of this x plus 1 by x minus 2 into x minus 3 into x plus 4. This is of the form numerator and denominator, so we call them as rational expressions. Okay, right. And square root of this expression. See, square root value exists only for positive numbers. If there is a negative number, negative term under this square root, you can't get answer, right? You will get a non-real value, and that's why you need to remove all those values of x which makes this expression as negative. And that's why our intention to find the domain is, for domain you need to find the values of x for which this x plus 1 into x minus 2 by x minus 3 into x plus 4 is greater than or equals to 0. We need to find the values of x for which it is greater than or equals to 0. Because if it is greater than 0, okay, square root exists. If it is 0, then also okay, because square root of 0 is 0, right? Okay. Now we need to solve this for domain. See how to solve it. We need to find the values of x by solving this particular inequality. As we discussed in the previous problems, see, you have to look at the denominator. So we need to find the values of x. For that you have to solve this inequality. To solve this inequality, see, first of all look at the denominator. This is, you don't know whether it is positive or negative. If the denominator is negative, easily we will send it that side. Okay. To make it as positive, okay, if the denominator is positive, we will send it that side easily. So to make it as positive, as we discussed for many problems, you just multiply both numerator and denominator with the same denominator. Okay, that means x plus 1 into x minus 2 into x minus 3 into x plus 4 divided by x minus 3 whole square into x plus 4 whole square is greater than or equals to 0. I just multiplied both numerator and denominator with x minus 3 into x plus 4. Now if you look at the denominator is two perfect squares, x minus 3 whole square into x plus 4 whole square. Something square is always positive, so the denominator here it is positive. Positive and positive, the total thing is positive. Since it is positive, the fraction is also given as positive, so the numerator must become positive. Okay, that implies x plus 1 into x minus 2 into x minus 3 into x plus 4 is greater than or equals to 0. Okay, now how to find the values of x if this particular product of the factors is greater than or equals to 0. To solve this, we use a technique. On the number line, we need to mark the roots or the critical points we may call. We need to mark the roots of this particular polynomial. Okay, if you multiply all these things, you will get a polynomial, right? And what are the roots of that particular polynomial? Since it is x plus 1, minus 1 is a root. Since it is x minus 2, 2 is a root. It is x minus 3, 3 is a root. Since it is x plus 4, minus 4 is a root. So we call that minus 1, 2, 3 and minus 4 are the roots of that particular polynomial. You just mark all those points, okay. Left side you have minus 4 and then minus 1 and then 2 and then 3. Okay, right. After marking all these points, since it is a polynomial, already I think we all learnt it from the quadratic and from the polynomials. If you wish to sketch the graph of this x plus 1 into x minus 2 into x minus 3 into x plus 4, the graph is just like a what curve shape, wave curve shape. Okay, the graph will be of the wave curve. See, yeah, after this 3, there are many numbers on the number line. You just take any number and replace in the place of x, you will get a positive value, and that's why here in this region this particular expression is positive. Since here it is positive, and in between 2 and 3 you will get negative, in between minus 1 and 2 you will get positive, in between minus 4 and minus 1 it is negative, and left side of minus 4 it is positive. Alternately plus minus you will get for these type of polynomial expressions. Okay, first of all you need to check for the last region. Okay, or in most of the cases we consider that in the last region, if you replace the values, if you replace x values there, you will get plus and then minus and then plus and then minus and then plus, like that we will get. Okay, just have a look. Okay, now how to solve? So always for this type of problems we need to consider the last region is positive, or if you wish, you just check it. Take any number, either 4 or 5 or 6, which is after the 3 we place in the place of x, sure you will get positive, so take it as positive. Since in that region it is positive, the next one is negative, and the next region positive, and the next region negative, and the next region positive. You will get alternately like this. If you wish, you just check by taking different values in the place of x. Okay, you just check any value by which is in between minus 1 and 2, replace it with x. For suppose 0 is there in between these minus 1 and 2, you just replace x with 2. If you observe, this expression will give us a positive value, and that's why positive. Actually we need to find out the values of x for which this expression is positive, and now we are just observing the rough sketch of this expression. This expression is positive in these 3 regions as well as negative in these 2 regions, but our requirement is the positive values of x for which it is positive, and that's why your answer is now this region and this region as well as this region. If you express all these 3 regions in interval form, see, less than minus 4 is minus infinity to minus 4, okay, union minus 1 and 2, okay, union 3 to infinity, and then we need to use the brackets, closed brackets or the open brackets. At minus infinity open bracket, at infinity also open bracket, and now see, greater than or equals to 0 actually. So actually, since equality sign is there, we need to use the closed brackets everywhere. Okay, this is actually a solution for this inequality, but when you think about this particular problem, see, the denominator is x minus 3 into x plus 4. We know that the denominator never be 0. Okay, the denominator will be 0 at x is equals to 3 and minus 4, and that's why you need to change these closed brackets to the open brackets at minus 4 and again at 3 to say it as domain for the given problem. And at the end, look at this, minus infinity to minus 4 union, closed brackets minus 1 to 2 union, 3 to infinity is the domain for the first one. Just have a look. So once again, look at the situation. See, we are trying to find the domain for the first one. Since it is square root, everything under the square root is positive. So to make it as positive, for that we need to fix the values of x. So this is greater than or equals to 0, right? So to solve this inequality, you just multiply numerator and denominator with x minus 3 into x plus 4. Then the denominator will become positive. You send these terms to that side. Okay, since it is positive, now you are allowed to send. Okay, now you have the product of these 4 terms is greater than or equals to 0. See, whenever this product is greater than or equals to 0, those x values we need to find. The product of these 4 terms, sometimes positive and sometimes negative. That's why we need to check whenever it is positive and whenever it is negative by taking different values at their roots of that polynomial. Okay, just like minus 4, minus 1, 2 and 3, right? And after these 3, the expression is positive, and from there onwards it goes alternatively with plus and minus sign. Since our requirement is to find the x such that it is positive, so this region and this region and this region are the required regions. At the end, this is what the domain for the first problem. So on solving this, at the end we have the domain for the first one as like this. What it is? Minus infinity to minus 4 union closed interval minus 1 to 2 union open interval 3 to infinity. Why? Because at minus 4 and 3 the denominator will become 0, okay? But if the denominator is 0, the value is not real, so you need to neglect those values for x, okay? Right, the first problem is clear and its domain is this, okay? Now what you say about the domain of the second one? See, first one is square root, but the second one is what? Cube root, okay? What you say about the expression under this cube root? Whether it is positive? Well, see, it must be positive or it must be negative. Is there any restriction on that expression? See, under the cube root, we don't have any restriction for that. Why? Because if you say, see, square root of 64 is 8. Okay, very good. Square root of minus 64 is actually not exist. Because under the square root, we can't accept the negative values. But what you say about the cube root? Cube root of 64 is 4. Okay, 4 cube is 64. And what you say about cube root of minus 64? This is minus 4. Okay, because if there is a negative thing under the cube root, no problem, still the results, the value will exist, okay? And that's why for this cube root, the domain is simply nothing but all the real values, okay? Just the values we need to eliminate, we need to remove from the real numbers are those x which makes the denominator as 0. And that's why the domain for this problem is nothing but all the real numbers minus the values at which the denominator is 0 are minus 4 comma 3, and that's why this is the domain. There ends the second one. And whereas coming to the fourth one, the third one, again it is what? Fourth root of. You just think about it. See, if this fourth root or fifth root or third root like that, if this nth root, n is an even number, that expression under that root must be positive. And that's why, since it is fourth root, this expression should be positive. And again, if you solve, the same domain is there is for this problem also. Minus infinity to minus 4 union, minus 1 to 2 union, 3 to infinity is the domain. And in the same way, when you think for the domain for the next one, it is fifth root, odd number. See, for odd number root, the domain is all the real numbers. Just we need to remove those values at which the denominator is 0. Okay. See, from this I think you have get an idea. See, if you have that nth root of that x plus 1 into x minus 2 divided by x minus 3 into x plus 4. That n may be any number. That n may be 100, n may be 1000, n may be 2020, no problem, okay? For all those problems, there are only two possibilities. If n is even, this is the domain. If n is odd, this is the domain, okay? So, just go through it. If n is even, then the domain is this one. If n is odd, then the domain is this one. So, for fourth root, fifth root, sixth root, seventh root, for everything we have domains now. If the n is odd, then easily we will say the domain. Just real numbers minus the values at which the denominator is 0. Whereas if n is even, we need to search for the values of x at which the expression is positive. Okay? Just have a look. This is another model related to the domain. Okay? Just have a look. So, just look at the board. We need to find the domain for these two. Right? When you think about the first problem, 2020th root of some expression and this is 709th root of some expression. See, this 2020 is an even number, this 709 is an odd number. See, since 709 is an odd number, so it is easy to say the domain. Why? Because every value of x is acceptable for this. Okay, take any real value in the place of x, for sure f of x exists, except the values of x at which the denominator is 0. See, at what values of x the denominator is 0, just think about it. See, if you take this x as 0, the denominator will become 0. If you take this x as minus 8, then this term will become 0, so the denominator is 0. If this x is 9, then this denominator is 0, then f of x won't exist. And that's why directly it is easy to say the domain for this particular problem is simply nothing but all the real numbers minus 0, comma, minus 8, comma, 9. Just we need to remove these three numbers from the real. If you replace any value in the place of x except these three, for all those values the function will exist, and that's why this is the domain. There is this problem. Okay, and now you just think about the first one. See, here it is 2020th root. See, since it is 2020th root, an even number, so to find the domain you need to consider this particular expression, x power 100 into x minus 5 divided by x plus 1 into x minus 7 to the power 11 is greater than or equals to 0. If this expression is positive, then only this nth root will exist, or otherwise it won't exist, and you can't say it as a function, right? And now in the next step, what we need to do, as we discussed in the previous cases, if an expression, a factor is positive, then it is easy for us to send that side. Okay, if a factor is positive, then it is easy for us to send that side. You just look there, x power 100. See, you just take any number in the place of x. Since power is 100, an even number, for sure it is positive. Okay, and here x minus 7 power 11. See, you just rewrite it like this. Okay, x power 100 into x minus 5 divided by x plus 1 into x minus 7 into x minus 7 to the power 10, which is greater than or equals to 0. Just rewrite that power 11 as 1 into 10. Okay, and now you just search it, think about it. This x power 100 is always positive. This x minus 7 power 10 is always positive, because the power is even number, so the result is always positive. Since these are positive, then the remaining expression should be positive, because the total thing is positive, right? Okay, since positive into positive is positive, since this is positive and the total rational expression is positive, for sure it is positive, and that's why x minus 5 divided by x plus 1 into x minus 7 is greater than or equals to 0. Now to solve this, again you just go with the traditional procedure. See, we need to make the denominator as positive, so you just multiply both numerator and denominator with x plus 1 into x minus 7. So I will write somewhere directly, x minus 5 into x plus 1 into x minus 7 divided by x plus 1 whole square into x minus 7 whole square is greater than or equals to 0. Now since the denominator is 0, you just send it easily that side. Then you left with this product as greater than or equals to 0. Since I have no space, and I will use it. Okay. Okay. So at the end, what we have in our hands? X minus 5 into x plus 1 into x minus 7 is greater than or equals to 0. Then how to find the values of x? For that, again you need to mark that on the number line. So if you say this as the number line, on that number line what are the roots? From the first one 5, minus 1 and 7. So somewhere you just take minus 1. For suppose here if it is minus 1 and then 5 and then 7. Okay. Then in the last region after that 7, you just take any value like 8, 9, 10, 11, any number and replace in that expression. It is positive. So in this region it is positive. So alternately if you work, in this region it is negative, here it is positive, here it is negative. Since we are searching for the positive region, these two are our answers. So minus 1 to 5 union 7 to infinity are the possible values. And then you need to finalize at the boundaries, minus 1, 5 and 7. See, at 5 it is 0. So you just take it as open interval. But at minus 1 the denominator will become 0. So sure it is a open interval. And at 7 also the denominator will become 0. So you just don't take that 7. Again use that open interval. So at the end this is the domain for the first one. And this is the domain for the second one. If that nth root, in that nth root if that n is even, you need to find the domain just by going with this procedure. If that n is odd, simply you just say the domain as the real numbers minus the values of x at which the denominator is 0. Okay, just have a look, go for a screenshot.